Every single organization on the planet, even our own careers, function on three levels. What we do, how we do it, and why we do it. Everybody knows what they do. Some people know how they do it, but very, very few people and very, very few organizations know why they do what they do. Two companies can have the same why, but what they do or how they go about advancing that why can be completely different. The fundamental basis of a why is deeply human, and it is that sense. It's the same thing that drives people to cults. We call it the cult of Apple or the cult of some company. Technology can't help find the why per se. It can help communicate it on a larger scale. What technology is wonderful at doing is spreading information, connecting us to people, driving the speed of transactions, moving at scale.
Les nouveaux business models, c'est quelque chose de très important. On voit à travers de nombreux secteurs en fait des leaders établis qui ont été mis à mal dans les dernières années par des nouveaux acteurs. Il y a quand même des catégories de business models. Par exemple, une catégorie que l'on voit dans beaucoup de secteurs, c'est ce qu'on appelle les low cost. Ce n'est pas toujours des nouveaux entrants. Vous prenez Renault avec la Logan, réinvente le modèle de la voiture. Très grand succès, c'est aujourd'hui le modèle le plus rentable de la gamme Renault. Et dans tous les cas, en fait, on voit la concentration sur un type de client, sur un segment client, et puis la modification de l'offre, produits, services, modèles de revenus. On trouve aussi, bien sûr, dans le domaine de l'IT des nouveaux business models. Le cloud computing ouvre des champs nouveaux. Donc c'est comme une activité de R&D, mais on ne fait plus que de la R&D produit, on fait aussi de la R&D en matière de modèle économique.
Continuous delivery is about making sure that your software is always releasable at the push of a button. With continuous delivery, it's not necessarily you're releasing every good build, it's just that your software could always be released. Services like Amazon, they're always changing things a little bit. They'll change where the buy button is, they'll change the drop down where you say the quantity. By having the changes be very small and frequent, it doesn't disturb the users. You have to think about how to make your software easy to use. And the feedback from your users is important, but also having a vision and doing usability testing continuously as part of your delivery process is essential. Quality is essential to continuous delivery. Quality has a value to users which should be quantifiable economically. One of the three goals of continuous delivery is about managing risk and making risk transparent. And so continuous delivery is actually a great way of mitigating risk.
A system can be deemed resilient if it can withstand unexpected errors and failures and degradations. Just software needs to assume that software is going to fail and that hardware is going to fail, that cables are going to break, that power is going to go out. So the resiliency needs to be an organizational effort, not just in the components themselves. After a failure happens, or an outage or a degradation, after your website goes down, have a post-mortem meeting and go over the chain of events that led you to that failure. I don't think you could find a CTO who would say, no, I don't want my system to be resilient. Building resiliency allows you to gracefully degrade. So when you have a resilient system, it has the ability to absorb failures without and still be able to continue some subset of its functioning.
Information technology progresses exponentially. It doubles in power every year. That means multiplying by a factor of 1,000 in 10 years. And it leads to surprising results. So you can buy $1 million of computation circa 1990 today for $1. But people get used to it very quickly, and we create new applications. Like social networks didn't exist 5 years ago because now they're cost effective. And most economic growth comes from the new opportunities created by this exponential growth. If we can actually send them in through the bloodstream with no surgery required, they'll become more and more popular. If you go out 30 years, we're all going to be making ourselves smarter by putting these computers in our bodies and brains. They'll keep us healthy from inside. They'll go inside our brains. They'll put our brains out in the cloud of computing. So we have to work on technologies that will keep them safe. And we can put in, for example, a rapid response system, a technological immune system that would detect new problems and counteract them. We have that, by the way, for software viruses. We need to do that for biological viruses. My big grand project is artificial intelligence, to recreate human intelligence in a machine. And I have some actual ideas about how human intelligence works.